That's a little blurry. That's better. Question. Which type of solution is best?
It's a ridiculous question.
False. Non-ideal solution.
Well, that's debatable. There are essentially two schools of thought, and it depends what you're using the solution for.
Non-ideal solutions can be separated completely. Non-ideal solution, separation, Battlestar Galactica.
That's not right. What is going on? What are you doing?
Last week, I was at the drugstore and found these glasses for $4. It only cost me $3 to recreate the rest of Adam's ensemble, and that's a total of $7.
What are you doing? You just ruined my perfectly pure water.
Don't worry about it, Adam. Water and IPA have completely different boiling points. You can separate them and get back your precious pure water.
No, you can't. That's a non-ideal solution.
Yeah, I know. And non-ideal solutions can be separated completely into their individual components.
Non-ideal solutions are not a joke, Will. Millions of distillation columns suffer every year.
Professor Michael?
Oh, that's funny. Professor Michael! Professor Michael, Will is saying that non-ideal solutions can be separated completely.
Yes, because they can.
No, they can't.
All right, you two, enough. Unit Operations Conference Room, right now. All right, you two. You clearly have no understanding of ideal versus real solution. As Thermomaster Michael Scott, I find it my responsibility to teach you. I am so good at separations that I wrote my own book, Somehow I Separate. Let me teach you guys about real solution versus not ideal solution.
Let's pretend that in each of these beakers we have a different component. The beads represent individual molecules of each component. The fact that we are using beads to represent each component highlights that the components are very similar. Each individual component has a certain strength of interaction with itself. However, because the molecules are very similar, the interaction between the two differing beads is essentially equivalent to the interactions between the individual components. This means that the solution can be treated as an ideal solution, and due to component similarity, the enthalpy of mixing is essentially zero. Let's consider a more common scenario, a real solution. If we have two components that differ structurally by a fair amount, like the cotton balls and beads, then we cannot expect the solution to behave in an ideal manner. This is because the molecules have individual interactions which differ from the interactions they have with each other. This is a more common occurrence when working with solutions, since the components you are trying to separate are rarely similar enough to display ideal behavior. Technically, there is no such thing as an ideal solution, but approximating solutions of similar components can often be a useful computational method. Two potential cases exist. First, if the interactions between the different molecules are weaker than the interactions between the similar molecules, then the enthalpy of mixing is endothermic and positive. A minimum boiling point exists that is less than that of either pure component as a result. Second, if the interactions between the different molecules are stronger than that of the interaction between the similar molecules, then the enthalpy of mixing is exothermic and negative. A maximum boiling point exists that is greater than that of either component.
So can a perfect separation be achieved?
Let me show you.
In the case of isopropanol and water, the solution does not behave ideally because the interactions between isopropanol and water differ from the individual interactions. When trying to separate solution components, it is important to consider equilibrium data. The equilibrium data for isopropanol and water shows an azeotrope, meaning, using distillation, we cannot separate the isopropanol from the water beyond the pinch point concentration of roughly 68%. However, some real solutions can be separated completely. Thus, once again, it is important to consider the equilibrium data when separating.
Alright, so I was right. Fire Will, promote me, make me the teaching assistant.
Adam, I cannot make you the teaching assistant, but I can give you the title of assistant to the teacher.